Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syami bin Zulkifli and my group member is Muhammad Rahimi bin Yusuf bin Ayub. Okay, today we're gonna do a lab 3 assessment that is Infinity Impulse Response IIR filter design. Okay, I'm gonna go through to the procedure of this lab. Okay, the first thing is we need to design the following IR filter with all frequency and magnitude specified in normalized form. Like filter 1 low pass 3 cut-off frequency of 2.0 band stop edge at frequency of 0.3 bypass maximum magnitude is 3 dB, stop band maximum magnitude -15. Okay, we need to insert of all these parameter in the coding. Okay, I'm gonna go through to the coding. The first coding is this. Okay, first you just need to copy the coding that were given in the procedure and paste to the MATLAB. As you can see, we need to run the coding and we will get this, the first space of the equation that it need. As you can see, I already paste like this for the first part. This is for the coding for the first part, and this is for the equation that the first part need. Okay, for the next part is we need to apply the parameter to the coding. As you can see, we using 0.2 and the dB is -3 and the maximum dB is stop band is -15 and the SP is 0.3. And as we run the coding, it's gonna show the first the magnitude response of the coding that we use, the parameter in the coding. Okay, for the next part I'm gonna only show in the in the report. Okay, this is 4.3, part 4.3. As you can see, in this part 4.3, they are a bit different in the parameter that we set, and the parameter that we set in this coding are similar to the 4.2, and the graph that we get is like this. Okay, for the next part is 4.4. Okay, for the 4.4, the parameter given is PS 0.8 and the maximum dB is -3. For the stop band is 0.7 and the maximum dB is -15, and the IR low pass were set to the high, and the graph we will get like this, and it start with the 0.65. Okay, this is for the next part. As you can see, it used two coordinate in the band pass 0.3 and 0.7, and it use -3 for the maximum dB, and in the stop band it also use 0.2 and 0.8 and -15 for the maximum dB, and the IR low pass filter was set to the band pass, and the graph we will get is like this. Okay, for the next part is, if we want to get the graph like this, we need to set the 0 6.2 and 0.8 for the bandpass, and it also set the negativity to the maximum dB for the stop band, set to 0.3, 0.7 and -15, and change the IR low pass filter to the stop, and the graph will come out like this. Okay, for the next part, Rahimi gonna explain his part.
Okay, Assalamualaikum. So I want to explain for the question and discussion. Okay, for the number for A, transform the 3 dB cutoff frequency of 0.2 and band stop frequency of 0.3 from the Z domain to the S domain using the bilinear transformation equation provided earlier. So from this we can see T is equal to omega P is 0.2 and omega S is 0.3. So we use the formula P is equal to 2 over T tan omega P multiplied by pi over 2. So we put insert the value and then we get the answer is 0.3249, and for S is equal to Z over T tan omega S multiplied by pi over 2, and then we got 0.5059. Okay, for the B, determine E and A shown in figure 2 for filter number 1. So note is 20 log 10 3 to the power of over 20 is equal to 3 decibel. So for the passband is equal to -3 decibel. So we put into the formula and then we got 0.9975. For stop band is equal to -15 decibel. Then we put into the formula and then we got 5.6243. Okay, for the number C, determine the transition ratio K and discrimination parameter K1 of the filter given the following question. So from here, T is equal to 0.3249 and omega S is equal to 0.5095. So we put into the formula K is equal to P over S, and then we got K is the 0.6377. So for the next, for K1, K1 is equal to omega over square root A square minus 1. So we just insert the value, and then for the K1 we got the answer 0.1802. Okay, for D is design a Butterworth filter that meet the filtering requirement set for filter 1 as described earlier using the following equation. The order of a Butterworth filter is approximated as follow. So we using the formula N is equal to log 10 1 over K1 and log 10 1 over K. So K1 and K we already get the value, and then we just put the value into this equation, and then we got 3.8 approximately to is equal to nearly to 4. Okay, for the E, convert the transfer function derived in exercise D into the Z domain using linear transformation. You may need to refer to equation 1 for the conversion. So we need to refer to equation 1, and then we got for the H over HS, we got the equation is 1 after we put the value into the formula, and then we got the equation is 1 over S square plus 0.2944S plus 0.1066 bracket, and another bracket S square plus 0.6033S plus 0.1066. is the equation. We change into the Z domain. Okay, lastly, for the conclusion, okay, in the end of our practical work, we managed to understand the basic concept of working principle of the IIR filter, the structure of the IIR filter, and the concept of certain basic IIR filter design technique. Also, we need to acquire the capability of designing IIR filter to meet certain filtering requirements. And lastly, we managed to complete this practical work, followed the procedure given correctly. So that's all for the lab number 3. Thank you, madam.